So welcome also from my side. Like a DevOps, recognize, analyze, and solve live problems with JDK and open source tools. And it's a 44th eBay Tech Talk, which I'm personally very glad, because right now it's not a good tradition to be 45th, and 44th sounds pretty much better, at least in terms of US presidents. So yeah, hi. Who am I? I'm a Java developer, architect, and open source evangelist. Started with Java 20 years ago. Then by 2000 I started building portals and maintain production systems. And 2007 I started MoSKito, which is not main topic of today, but I will drop some words about it. So it is not another DevOps culture talk, but we have DevOps in title, so I have to at least drop some words about it. So I don't know, you should know this picture already. It's in the media since 2013, something like this. Ominous wall of confusion between devs and ops, and how they're not speaking to each other and throwing stuff over the wall. So obviously it's not DevOps. But what I'm understanding when I'm talking about DevOps, it's not a system administrator who can program a little bit shell script or create a Jenkins pipeline. But when we talk about DevOps, we talk about developers and op teams building software together and running software together. So like Amazon says, you build it, you run it. And in best case, they have a tool that will help them doing it, but more on it later. Okay, quick question. Anyone here uses Java 9? Okay. Anyone here using G1? G1 in production? Okay, nice. Okay. In the good old times, we had production systems closed away in safes for years. Actually, I had a project in 2007 at Payback, and we had to develop a Payback toolbar, and then we asked, how fast can we get this to production? And they told us, we have a slot open in 15 months. So back then, software was built, was tested, and was running without any change for very, very long time. This time is obviously gone. Now we have systems which get features every 10 days, every 7 days. Some systems get updated 10 times a day, 100 times a day, you know the names. But not only this, also you have changing markets. For example, we are running a site which is a dating site, and 1 year back we had 60% desktop and 40% mobile, and just in 1 year this completely turned. So now we have 70% mobile users and 30% desktop users. And of course this different usage influences how you maintain your site. And all these changes, they mean challenges, and to master challenges you need tools. So, a little story, why you need tools? Because people without tools use logs for everything. And in 2003 I was started to work for FriendScout, and by then they had really huge traffic, and about 15 servers, and the servers were not very stable, and we had problems here and then. So obviously DevOps wasn't invented back then, and we had system administrators, and they thought it would be a great idea to watch logs. So what they did, they wrote a log watcher which would monitor any occurrence of fatal. So when you have fatal in the log, they would restart the server. And it was great. Until one day a user called support and said, I don't like your shitty site, because whenever I log in it crashes and I have to log in again. And I do it 3 times a day, and whatever time of the day it always crashes. And then we asked what was the name, and she thought her name was Femme Fatale. So whenever she was logging into the site, Logwatches has seen fatal in the logs and then restarted the server. So this is my toolbox. I mean, there are obviously many tools, but this is basic tool set which you should have. And on the first line, we have standard Java tools like JMap, JStack, JHat. If you happen one day to have Java 9, you will have the new flight recorder, which is very promising. Then you have APM tools like MoSKito, GlowRoot, or GDBC Performance Logger, just for log statement execution. And I made personal experience that coffee and a shower helps a lot to solve performance problems. But the most helpful thing for performance problem is an ear, is a listener. So if you find someone who you can tell your problem, who you can tell all the details. So from my personal experience, about 70% of the time after 10 sentences, I know what the problem was, because when I explain it, I understand it myself. Okay, so changing systems mean challenges. Most of them are performance challenges. When we talk about performance challenges, we talk about memory, threading, the 3% bugs, performance bugs. Then we have the what the fuck bugs, my personal favorites, Heisen bugs. No sane user will ever try these bugs. And finally, we have Friday releases. Who loves releases on Friday? Anyone? Who has to do them anyway? Yeah. There was a time in Germany when we had 2 large matchmaking companies. They now belong together, but back then they had fights. And what they would do, they would make a legal statement to the other company, and they would time it so it comes on Friday. And you have to react within 12 hours. So every Friday, every one of these companies would have a release. They loved it. Okay, so memory challenges. When we talk about memory challenges, so, okay, of course the out of memory exception, everyone knows, easy to find. But then we have the continuous full GC, which is not so easy to find because it doesn't show up in logs. Then we have perm or metaspace, depending on JDK version. So if you have a site with a lot of Java server pages, you can run currently in a perm space problem. Then there is a cache space most people aren't aware of. The cache space is used by the hotspot compiler. And if you run out of the cache space, the hotspot compiler can't compile anything. So you will be just slow without understanding why it's happened. Then we have memory leaks. There is one talk in Hamburg scheduled for next week with someone pretending there are no memory leaks in Java, but actually there are memory leaks in Java. Especially if you're playing with class loaders and thread lockers, then you are entitled to get a memory leak. But also with Spring and GC Leap and agent instrumentalization, there are pretty much possibilities to get a memory leak. And then there is simply I'm out of heap. Happens. So this is an example of full GC and what happens then. On the above chart, the blue line is the number of requests to a service, and the red line is the average response duration, and both in percentile, so it's 100%. And on the lower chart, the red line is the guest page, the home page, and the blue line. No, the red line, right. And the blue line is the welcome page. This is the first page the user sees after he logs in. And what happens here is, due to a full GC, the average duration, the service was still available, but was very slow. So the duration went up to the ceiling. And as a result of it, the welcome page, the login page, lasted 60 seconds. Of course, no user would wait 60 seconds, so they would try to log in again. More traffic on the service, even more wait time. But how can you deal with it? So to deal with it, you need to manage your garbage collection. The ultimate guide for proper GC settings in Java 8 and 9 is actually one line. So if you want to let GC do its jobs in 95% of the cases, it's enough to just tell him how much memory he can use. This was something I took from my server yesterday, like a real-life example, because in Java 8, G1 GC is not yet standard. It's standard in Java 9. So in Java 8, you have to tell them to use G1GC, and also in Java 8, it's now standard behavior, but in Java 7, you have to tell the garbage collector that explicit GC shouldn't be executed. Now, when you manage your GC, you must understand what's happening with your GC. So these are the GC log settings for actually almost every garbage collector out there today. So these are the Java 8 settings. For Java 9, they changed the logging system completely. So Java 9 now has a new unified logging system, and there's a link in the bottom to the new Java 9 logging system. But you can just copy it. It's not from me, it's from Kirk Pepperdine, who is one of the most recognized experts in performance. So once you have the GC logs, you have to read them. So before the G1GC, it was pretty easy to read the GC logs because it was actually sufficient to grab for full. And when you grab for full, what you see is here it's 6 GC runs. You see all of them are full GCs. They last about between 2 and 4 seconds, which is, well, not optimal, but okayish for this particular service. But what you also see here is that the GC is able to free about 100 megabyte. So you can see this number in the middle of the second line. And the amount of used memory was about 2 gigabytes at the beginning of the GC run, and then it's 1.9 at the end, which means that this system needs obviously more memory. But it's hard to read logs. So instead of reading logs, I'm preferring to look at charts. So this is a chart from the same GC log. And here you see that the server has very low memory, but it's still working, and the amount of the GCs, the number of collections is not so high. But same server, actually a couple of hours later, and you see on the right side this, I don't know how to say it in English, this Sägezahnkurve in German. So if you see something like this in your logs, then you definitely have a problem, because this means that you are very near to a full GC and you need either more memory or investigate what's happening here. So this is from the parallel all GC, and it's really pretty easy to read. And this is the output from G1. So it took me a while to understand it, and it is only one collection run. I tried to make things bold, which are important. So for example, the G1 makes similar output for young collection and for full collection. But full collection isn't called full anymore, it's now called mixed. So if you see mixed in the top, it means that you have a full collection. And below you see what happens with memory. So in this case, we have read 400 megabyte, which is about 10%. And the most important thing, the amount of time the application has been stopped is below 0.2 seconds, which is the default setting for G1. G1 promises you not to make full stop the vault, but it says mostly not stop the vault. So it means it will stop the vault, but it will try to make it short. And in this case, it will, with default settings, it will try to maintain 200 milliseconds as limit. And this is the one thing that you can actually change and you can actually demand from G1. Okay, so if you have trouble reading the logs, there is a great tool. It's called gclarity. Unfortunately, it's not free, but there is a free version for 1 week. And you can read the GC logs for G1 or Shenandoah or all the fancy collectors out there. By the way, someone used Shenandoah here? No. Okay. Okay, so once you read your log, you have to understand what's happening with your memory. And in case the memory is increasing, what is eating it? In Java, it's pretty easy to make a heap dump. You with jmap, and then there's another command jhead to analyze this dump. The problem with jhead is if your memory dump is a little bit bigger, like, I don't know, 10 gig or maybe more, then it lasts about 20 hours to get it. And you need at least double amount of memory in your jhead to load a huge jmap dump. So instead there's another tool which is called histogram, and you can use jmap to produce a histogram. And the histogram is actually a count of all objects in the system. So it produces this nice file, and you see a number of instances and how many bytes each object takes. It doesn't provide you the relationships between objects like the heap dump would, but it gives you an idea what's happening. And also gmap gmap histogram is a real great tool to force a full GC if you want it. So if you, for some reasons, want to force a full GC, you cannot do it from code anymore, but you can do it with jmap-hip. Okay, so once you have your histogram, I mean, looking at this, I see, okay, I have about 100,000 of an object, and no, 1 million of an object, and 100,000 of another object. But how do I know which one of them is causing me troubles? And the solution is easy, is always with performance management. You should monitor not the state, but the change. So take multiple histograms and compare them. And then you can see that one particular object, that an object remains the same, but another object changed. So this is obviously your most potential candidate for your memory problem. Of course, doing it manually is hard. So there are a lot of tools. I have also one which takes two histograms, analyzes it, and then it prints me what is the change. And I see that another object gained 150,000 objects, and I can see I can start dig what is the reason for it. Actually, another thing which histograms do is if you really have a class leak, so a memory leak based on class handling, like you have your own class loader and classes don't get collected, or you're using cgleaps with Spring. Cgleap produces new classes whenever you initialize a Spring context, and if you do this like in every request, which some people do, then there are some bugs in Spring 3, if someone still uses Spring 3, which lead to problems with not collected classes. And you would see a lot of classes with $something, same class $something in your histogram. Okay, another topic, concurrency. Concurrency produces a lot of problems, and as we started with FriendScout, I had a colleague there who was by the name Oliver, and after we had users over user complaints, he formulated his first rule of concurrency, that if you have enough concurrent requests, any condition in your code which is marked can't happen, will happen. And it really will. And after we fixed a couple of bugs, then he came to the second rule of concurrency, that after you fix it and you're sure that it really can't happen now, it will. So concurrency is really a bitch. And I have an issue which happens to Tomcat with concurrency. And this issue led to, until now, most commented, upvoted, and discussed bug in Tomcat and a servlet spec change. The change between the servlet spec 2.5, I think it was in 2.5. So what happened? An very talented developer who was eager to get some more performance has decided to remove synchronization of session attributes and to reduce synchronized map with a hash map. Now you must see that hash map isn't designed to be used concurrently, but in most cases you really have to have a lot of traffic on it to see what happens. And what happens if you have readers and writers at the same time, and the writers are not only changing but adding new attributes. So by adding new attributes, the hash map will be changed structurally. It will change the order of the buckets and the links between the buckets. And if at the same time you would read in the hash map, then it can happen that your read thread will get caught in one particular bucket of a hash map and will create a very nice infinite loop. Which means that if you have 2 CPUs or 4 CPUs in your server, one of them will be occupied with reading from hash map, and after 4 such threads you are out of CPU. So this actually happened to us. We had a payment server, and payment server, it's not the server which is usually under much load, unfortunately. So it had only 2 CPUs, and then one of the CPUs was managing hash map reads, and then the other one, and no one could pay. And it was pretty embarrassing for our supervisors. Okay, another issue with threading is that threads are used in the Tomcat and in containers and applications generally to communicate with the environment. So these are my killer Chinese, and what happened here was that about 3 years ago there was a huge problem with milk in China. So they had some problems with factories, and the milk, baby milk, was contaminated, and actually children died. And they started to buy this milk elsewhere. So what they did was they started to buy it in Germany, and in Germany you could only buy it in 2 online shops by that time. And you must imagine China with 1.5 million people has a little bit greater demand than Germany with 70 millions. And the milk in the stores was sold out the moment it got there. So what they did was they created some scripts which would continuously make search requests to the site to check for the milk, and as soon as milk was there, they would try to buy it. But the problem is that China is far, far away and behind a firewall, and this firewall is not nice to connection issues. So we had, like this, on the top side you see normal threads. In this case, a good old blocking connector. So you have the green line is the amount of total threads, and then you see running threads, the threads are waiting. And so on top you see the normal behavior, and in the bottom chart you see that at some point the blue line is starting to rise, and then the server is run out of threads, had to increase the total amount of threads, and they were all waiting to stop to terminate the connection, and as the server couldn't add any threads, it stopped serving. So how to deal with threading issues is obviously monitor it, and monitor it for, when you monitor it, you have to monitor for 2 types of threads. It's for runnable threads and of course for blocked threads, because as soon as you have blocked threads in your system, you have some problems. Now the other source of threading issues are the infinite loops, which like the one I was talking about in Tomcat. But thankfully Java provided us with a tool, and it's called the JStack. And with JStack you can see different states in which threads are, and obviously there are some threads, there are some states for runnable. When you see like socket accept connection, it's which states which are legit, and you see other states that what you wouldn't expect it to be. So for example, in the lower screenshot, the infinite loop class, obviously you wouldn't expect that your thread is stuck in a class somewhere just in some line of code. So if you make a JStack and you see that your thread is running in same method, in same line of code, then try to make another JStack 30 seconds later, and if it's still there, then you have something going on with your application. Also, one other thing that happens actually only in Java, if you see threads runnable in points of place where you do not expect them. So like nothing happens in this method, so why is here? Why is my threads here? Then it can be an indicator for another problem, that something is stopping, something is interacting with your JVM, and you have to investigate it. Okay, so I talked about the open source, the standard tools. Now APM. APM stands for Application Performance Management, and when your standard JVDK tools don't help you, you need bigger guns. So APM provides those guns. Yeah, because the title of the talk was not only the JDK, but also open source APM tools. Now we're going to OpenM. So one particular issue where you have APM tools helping you with are performance problems. The quote, we should not forget about small efficiencies, premature optimization, all this stuff, everyone knows it. But what most people do not know is that this sentence has a second part. Yet we should not pass up our opportunities in the critical 3%. So this is an example of code where obviously a performance problem could occur. Anyone sees it right away? Okay, so calling in logs to remote service is obviously, or to a service to another component, is wrong for multiple reasons. One is because you actually get two different results. So between the log debug and the if the result could be changed, and other is that you're just throwing away performance. Things like this hard to find in production, but if you have APM tools, they provide you with stack traces. So for example, this one is taken from MoSKito, but also AppDynamics, New Relic, to name commercials, they also provide this. So in this case, you see that during the execution, you see in the 7th and 8th position, same call is made, and actually 56 milliseconds is just spent, thrown away. And in case with MoSKito is actually automatically detects it, and it will show you that you have a double call execution, and you spent 110 milliseconds. Okay, another thing which you can handle with APMs are performance bugs. This happened a while ago. We have released a new version. We were everyone happy, celebrating. Then DB administrator comes in and says, we have traffic increased by 150%. And if it continues, we will not survive the evening. Problem, 20 clients in the code. So 20 different components in the code are using this database, are using this service. So thankfully, an APM showed us that all the traffic, or a huge amount of the traffic, came from one source. And we were able to make a quick inspection on this source, and it just turned out that someone used wrong Boolean equation. So instead of checking flag, is user admin, and then do something complicated, he first did the complicated stuff and then checked, should I do it at all? Problem solved, 30 minutes, everyone happy, but without knowing where it happens, it would take us hours of looking. Okay, so talking about APM, and a little bit about MoSKito as an APM, but also same things are in all other APMs. We have first producers, so something that produces statistics. So statistics are code execution, statistics, method calls, duration of calls, this kind of stuff, but also payment service, mail interface, this all interfaces, they all produce statistics. And the statistics can then be evaluated and accumulated and charted. And you can use the charts to analyze the data. When you have charts, then you can analyze the data visually, and with visual analysis, you can set the thresholds. You know what is happening and what are the thresholds for my application. And finally, there are journeys. So I will skip this for now because I want to show you the journeys a little bit later. And so MoSKito, or any other APM for this matter, usually has an agent. This agent connects to your application and has multiple data points where it connects the execution times and so on. And within the execution times, we have different statistics. So like every method called would be a different statistic value. And each statistic, like method call or credit card payment, would have multiple values. For in case of method, the value is request, duration, is this an error, is this the error rate of the method, the average last min duration, and all this kind of stuff. In case of payment, it could be the volume. In case of an email, it would be type of the email, the route of the email, and so on. And all this data, which is gathered, this is best if your application management tool allows you to inspect it in intervals. So it doesn't make much sense to look at the data which is collected over a long period of time, because then data becomes insensitive to a change. So if you have a database which is pretty fast, and after some period of time you have increase if in execution, then the average duration will take a while before it goes up. But if you're looking at 1 minute interval or 5 minute interval, then you will see it immediately. So once you have it, there must be a tool which just helps you to discover and analyze. And one other thing that you should have is overview. And I will show it in live, but you maybe remember that I had this friendly face for Dev and Ops for their work. So MoSKito actually has this, and it looks exactly like that. And in this case, the system works like expected, and this is a case where it obviously has some problems. But okay, everything we've talked about now was managing an application which is already running. Now, of course, the best thing would be if we could solve our problems before we have them. And so before I'm releasing software, if I can detect the problem before I'm releasing the software we're putting into production, then obviously I would save my company a lot of money and be a very valuable employee, even on eBay. So to do this, you can work with an APM, and I'm going to show you how. Now, this, I hope you are not hungry anymore. This is a demo application. It sells burgers. And yeah, this is what you can do. It's actually live, because a little bit slow, because it now runs somewhere in a cloud. You can select a bread here. So for example, I take a burnt toast and take a nice red and also a cockroach to my burger. And I can order it here. And I have ordered it. I got customer ID. It was assigned to me dynamically. And I can now go and pick up my burger in Timbuktu. So now this is my MoSKito dashboard of the same burger shop. And I can see different, can you see the numbers? I don't think, I make it a little bit bigger. Okay, so what I see here are different parts. And I see, for example, the execution of my burger shop. So there is a service in the shop which is responsible for placing orders, and I see that I had 6,000 requests and it took 750,000 milliseconds. But as I said before, since the running of the system is a lot, so let's look at smaller time frame. So last minute I had 4 orders in the system, and I see what's happening here. Now with this information and the charts, I can build a dashboard, and this is my nice burger board where I can, on the one side, control my technical information, like what is happening here, how many threads are running, sessions, memory used, and so on. But on the other side, how many orders have I got, and are the orders where I expect them, and how fast is my system answering, and all this stuff. Now the interesting part of this is a feature called journeys, and this is something that I wanted to show. And we take a new journey, and so what happens now is that I'm ordering another burger, and I see what is happening in my code when I'm executing this request. And in this case, I triggered this by adding a specific parameter, clicking a specific link, but it shouldn't be the case. I can do it by adding header to my REST request, by some flag in the database, by whatever reasons. I just can, if I want, I can add journey to everything that I'm calling. And if I look into this, then I see what happened in my application. Oh, sorry. What happened in my application? So I see an order controller, obviously a class has been called, then shop service has been called, some methods, an order has been played, and it returned an burger, bread, meat, and with pork, cheese, and wholemeal for 15.55. So this is for one call, but the other thing that I can do is I can ask MoSKito to, and I can do this not only with MoSKito, but also commercial tools do this as well. I can see what part of my application is eating performance in my journey. Now, this is a very small example, so there will not be happening a lot here. So I see that there are notification service and some other service. One service had 3 calls and duration of 110 milliseconds, and the other service had 6 calls and not measurable duration. So this is simple. But if you have a huge application, you will see which classes in your application are going to consume the performance. And what people are doing with it, and for example what Parship is doing, and this is the best before release part. So they before each release they're doing an automatic load test with all sessions recorded, with all monitoring journeys recorded. And they ensure 2 things with it. First, they compare the journeys, the size of the journey, the amount of elements in the journey with what they are predicting. So by doing this, they know that the test users with which they perform the load balancing is actually doing the right thing. So their load balancing are actually doing something. Not load balancing, sorry, loading. So their load is actually providing load on the system, and it's not just firing some easy to answer requests. Because previous to that, they have problems that if a user wouldn't have VIP rights, he would become not a full suggestion list, but only a short suggestion list, and a short suggestion list would have less impact on the system. So the load test wouldn't be comparable if the users are not comparable. This is one thing. But the other thing is they can ensure that the release they're putting live produces same results as the release before. And they know that they haven't added any slow bottlenecks to the system. Okay. Now we have like 40 minutes. If you want some questions now, or we can, or do you want more details on this? I'll let you decide.
Okay. Do you have other tools to do this canary testing so that you have live traffic, something like that, and put it to the test system?
Do you mean the traffic or the performance data?
The traffic for the performance measures.
Okay, so what people usually do is to use some kind of HTTP proxy. And there are a lot of HTTP proxies out there. So I know that NTT, they are using, I forgot the name of this HTTP of this proxy actually. But what they do is they have the data collected at load balancer of a system from one server, obviously, and then with this HTTP proxy they would collect it and then send it back to the system. What we do with MoSKito is we can collect what's happening and replay it, but it's more on class call level. So what we do is, for example, we can see, load already. We can see which requests have been called, how often, okay, this, and which URLs have been called, and then we can replay it. But actually every kind of HTTP proxy would do it. Okay. So at least for web servers, right?
So question is, what kind of instrumentation is this using? If I'm not using Tomcat or servlets or anything like that.
This thing, instrumentation. So it's a question about integration, right? Okay. So MoSKito has multiple ways of integrating. Thanks for the question, by the way. And I have not the proper slide here because it was not so much about MoSKito, but there is an integration guide on the side. So this one is AOP. This means that your code, the service, the shop service I was talking before, this is just a regular Java code. Can you see it? Okay. Okay. Yeah. Where's the presentation mode in Entity? Sorry? No, I have another key settings, but I think actually there will be here as well. So you just have a class and you just have to add this monitor annotation, and you can add this monitor annotation on a method or on class, and you can also exclude something from monitoring by adding don't monitor. But annotation is one thing. The other thing, what you do with this annotation, and there is a AOP-based compile time weaver. So you can use a Maven AOP plugin and make compile time weaving for it. But the same annotations for CDI. So if you are in the EGB world, then the same annotation, but they work as decorators. And another thing is, if you don't want this, you can use proxies. And proxies are Java proxies. So you just have to add a wrapper around your method, or MoSKito creates a wrapper for you, and then everything is monitored. Problem with this is it's a little bit slower because it happens in runtime. And finally, there is an agent. So if you don't want any of it, if you don't want to change your source code, there's an agent that you just can load and tell the agent, please do everything in my package, and then everything in this package will be monitored.
what is the performance impact of the instrumentation?
Okay. It's funny. I was at Java 1 2 weeks ago, and someone made a talk about this. He took MoSKito and Glowroot and a third agent, open source agent, and tried to make some comparison between how much overhead it provides. And he had really funny results, because in his results, not instrumented code was slower than instrumented code. I don't know how this happened to him, but actually he had this result. And okay, it may be wrong measurement, it may be hotspot games, because hotspot found something he could optimize better in instrumented code. But general, it's far below 5%, and in most cases it's about 1–2%. But of course it depends on the amount of classes you are going to instrument. So if you have like one class and instrument it, then you don't see anything. If you instrument every pojo, every bean, every method, so basically what happens if you run New Relic and say monitor everything, then you will see a huge performance impact. So this way, what you usually do with MoSKito, and you concentrate on layers, you concentrate on important components like services, controllers, stuff like this, but not on beans. And then you don't see it. And the other side is memory footprint, if you are probably your next question. So same applies here. If you have a huge application, your memory footprint would be relatively large, but still very low compared to the size of your application. So if you have like heap von 10G, then having additional 20 MB or something for memory footprint of your monitoring won't hurt you. If you have a small application with a couple of classes, then the memory impact will be some kilobytes. But you can use JMap with histo option, and then you can see it exactly.
Okay, and you have to aggregate all these meters and stuff. And what do you use? It's an own server at best. I think if you do it in the application itself, it would be better.
Depends. Well, question is, if you have a lot of data and you send all this data away, then you should know where you're sending to. So if you have a commercial agent which sends the data to a US data center, and then in Germany or in Europe in general, you can get some problems. So what MoSKito does is MoSKito creates averages on the fly. So it doesn't store every measurement, but it accumulates them on the fly, and you have for every interval you have and for every value you have the current value, the currently counted value, and the last value. Then if you want to maintain your data history, then there are other components. MoSKito provides an interface, it's called MoSKito Central, where you can plug in some storage. So what we do is we use usually Mongo and Elasticsearch. Elasticsearch for querying, and Mongo to be able to reproduce our data, because Elasticsearch has a tendency to crash from time to time. Or if you want to modify your schema. Sorry? Scala. Everything that runs in the JVM can be monitored. It's also the same for JRuby, JPython, J something. Also, in this particular case, and I think it's the case with most tools, we have interfaces where you can provide your own data. So we had a case when we had a business processing engine. And our system, the system we built, and this business processing engine with some business rules and workflows and fancy stuff would cooperate to perform some task. And we didn't know, is time consumed in our application, or is time consumed in the call to this workflow engine, or in the call from the workflow engine back to our application. So what we did, we added some code to the business processing engine that it sent us the data, and we could immediately compare execution in our code, execution in their code. go away. Go ahead.
I have another question regarding non-blocking codes. We have a lot of non-blocking software out there at the moment, and if we do the instrumentation and the declaration, what does it do with the non-blocking code?
Well, it doesn't do anything bad to the non-blocking code in first line, but problem with non-blocking code, and I was talking particularly also to New Relic about this. The problem is that you don't have a trigger to start monitoring. So what MoSKito does is we have a concept called tracers. So if we have this shop service, for example, we can say, and it's on right now, we can say whenever something passes this line of code, so this produces this class, not line of code, but this class, I want to know about it. And here, it collects automatically all the calls to this component and tells me where it comes from. So I see basically the stack trace, starting with some Tomcat internals and so on. And it shows me, I have to learn how to click, what's happening then. And then I can submit a policy. I can tell I want to have longest request, or I want to have request with errors or something like this. And it collects, because obviously you cannot collect every request, but you can collect limited amount of requests. And this policy limits it to like 50 longest requests in your application during a day. And then after a day of running, you can check and you can say, oh, I know now where this problem comes from. Because we have, I don't know if you have it in your system, but from time to time you have like so very strange requests. The system is permanently perfect, but twice a day something peaks.
So I guess it's very hard to get a system which monitors semaphores instead of threads, something like that. And the non-blocking stuff, threading may be no problem anymore because you have an upper bound on your thread you need at all. But within one thread, there is a lot of stuff going on, a lot of requests within one step. Does it have some impact on how to build APMs, on how to build... I know that for debugging, for example, and reactive programming is a real problem, it's a pain in the ass. So, yeah. Have you...
Yeah, what we do is, so in, we didn't do it for Vertex or something, but, and I think you are talking about Vertex, it sounds like, okay. But we have done it for, let's say, microservice rich systems, where you have calls getting to another service and another service and another service. And we needed to do some customization, and I think it's something that you, as a user of an APM tool, have to do. So what we did was, whenever a call to a microservice went out, we added a special flag to it. And on the other side, whenever a call came in, we read this flag, and we were able to create this kind of stack traces over all components. So we knew that user XY whatever is logging in, and now it's call ID 217. And this was created on all microservices which were in touch. And then this depends on your tech. So we did it for RMI-based framework, where we could transport this information via piggybacking. So what we did, the last microservice in the row would collect this information, and then it would send the monitoring information along the data. And then the first service would collect all the stack traces from all, or execution traces, not necessarily stack traces, from all the services it asked, and then you see network component, because you can compare times, and you see where the request went to.
The idea is to do something like storage. So this You know slows?
No. How is that?
Slows. S-L-E-U-T-H.
Not yet.
Okay.
I will probably have to.
Okay. So it sounds similar, but they do it for HTTP, for messages about over brokers, LPQ, stuff like that, and they try to put correlation IDs on the messages and then correlate the calls.
Yeah, there are actually a lot of tools nowadays which all do similar stuff a little bit differently for kernel case, and you have to pick one which is best for your case. Okay. So no further questions? Then, Katja, back to you.